Hey there and welcome. Today, we're going to break down the absolute must-knows of Java's object-oriented programming. And we're not just going to give you textbook definitions. Nope. We're giving you the exact way to explain these concepts so you can walk into that first tech interview and absolutely crush it.
All right, let's just jump right in. Imagine this. Your interview is booked. The clock is ticking. You know it's not just about what you know, but how well you can explain it. That's the skill we're going to sharpen today.
So this is it. This is the big one. You can pretty much guarantee this will be one of the first questions out of their mouth. It's kind of the first hurdle you have to clear. So how do you answer it with confidence?
Keep it simple, don't overthink it. At its heart, OOP is just a way of thinking about code. Instead of writing a super long procedural list of commands, you think in terms of objects, little bundles of data and functionality that mirror things from the real world. It just makes everything so much more organized and easier to manage.
And this is where the classic car analogy becomes your best friend. Seriously, use it. A car is an object, right? It has properties, things that describe it, like its color, its brand, its current speed. And it has behaviors, things it can do, like start, stop, or accelerate. OOP lets us build that exact model right into our software.
Okay, so we have these objects, but where do they actually come from? To get that, we need to talk about the huge difference between having a plan and, having the actual thing. This brings us to a super important concept, the blueprint versus the building. First up, you've got the class. The class is the blueprint. It's the cookie cutter. It's not the actual car. It's the design for the car. It lays out all the properties and behaviors that any car made from this design should have.
And then, from that one blueprint, you create objects. These are the actual buildings, the actual cars rolling off the assembly line. An object is a real thing that exists in your program's memory, and each one can have its own unique data, like a red Toyota or a blue Ford, all from the same car blueprint.
And right here, this is where you really start to see the magic of OOP. We write the student class, that blueprint, only one time. But from that one class, we can stamp out tons of unique student objects, Alice, Bob, Charlie, each with their own name, their own ID, their own grades. It's all about reusability and efficiency. It's a total game changer.
Now, for one of the big pillars of OOP, encapsulation. We're not getting into inheritance or polymorphism today, but you have to understand this one. And the easiest way to get your head around it is to focus on its number one job, keeping your data safe.
So, why bother protecting your data? Well, think about it like this. What if the data inside your object was a bank account balance? If you just leave that data out in the open, any other part of the code can just reach in and change it to whatever it wants. It could set your balance to a negative number. That's not good.
And that's where encapsulation comes to the rescue. It's like putting a vault door on that data. In Java, we do this by making our variables private. Now, the only way to change that balance is by going through special public methods that we create. These methods act like security guards, so our setBalance method can check, hey, is this a valid amount, before it allows the change.
This slide just lays it all out, right? The risky way versus the safe way. But here's where the interviewer might try to trip you up. They might ask, well, if you have a public method to change the data, what's the point? It's still accessible. And the perfect answer is, the point isn't just about hiding, it's about controlled access. We now have a place to put logic, to validate data, to make sure nothing crazy happens. That control is everything.
Okay, let's talk about another big concept, one that people mix up with encapsulation all the time, abstraction. If encapsulation is about hiding data, abstraction is all about hiding complexity.
This car analogy is perfect for this. Encapsulation? That's the engine cover, hiding and protecting all the greasy parts from being messed with. Abstraction? That's the steering wheel and the pedals. When you drive a car, you don't need to know how the fuel injection system works, right? You just need a simple interface to make it go. That's abstraction.
When you're writing code, this just means giving people a really simple, clean way to use your stuff. They don't need to know the 10 complicated steps it takes to connect to an email server and send a message. All you give them is one simple method, send email. All that messy complexity is hidden away.
All right, you've nailed the basics. You're feeling good. Now the interviewer leans in. They want to know if you really get it. They're about to spring a trap, and this is how you're going to see it coming and walk right around it.
Okay, listen up. This is super important. This is one of those moments that can totally separate you from the other candidates. It shows you didn't just memorize some terms, you actually understand the language.
And there it is, the question. It sounds so simple, right? Is Java 100% object-oriented language? The easy answer, the one that feels right, is not the one you want to give. So the wrong answer is just saying yes. The answer that's going to get you nods of approval is no. And here's the crucial why. Java has primitive types, things like int, char, boolean. These guys are not objects. They're just simple, raw values. This was a choice made on purpose for performance. Then, you can add the bonus point, Java gives us wrapper classes, like integer, for when we do need to treat them like objects. That answer shows you know the nuance.
And hey, if they circle back to encapsulation at any point, just remember this killer line. It's not about hiding, it's about creating safe, predictable, controlled ways for your program to interact with its own data. It's all about that control.
So there you have it. You've got the blueprint, the safety capsule, the simple interface, and the secret weapon for that tough interview question. You're not just ready for the questions, you're ready to actually start building things. So the only real question left is, what are you going to build first?